Big Bang Theory and complications. Is it possible that the universe gained energy in its beginning from surrounding objects or even space vacuum itself? If their energetic spin is great, formed a singularity. Starlight universe pod that was unstable. The vacuum of space is filled with quantum fluctuations, where particle-antiparticle pairs can momentarily appear and disappear. Quantum fluctuations can lead to observable effects, such as the Casimir effect, where force arises between objects due to altered VA.
We don't really know what the universe truly looks or is like, so its end could manifest in many ways. If the universe continues to expand, energy will be spread out so much that eventually all areas within it will remain at the same temperature. We call this the Big Freeze, when interactions between particles will cease and the universe will remain at a frozen standstill forever. But if you don't fancy the idea of a cold, dark, barren universe, then don't worry. There are still more morbid possibilities for how the universe will end. As we know, the universe is accelerating in its expansion. If it carries on expanding at this ever-increasing rate, it might expand so fast that gravity can't hold anything together anymore. The Big Rip will occur, and everything from galaxies to atoms will be ripped apart. All that will be left are single particles traveling through a seemingly empty, timeless space. There might still be hope, as some scientists say that the universe won't expand forever. The Big Bounce theory suggests that, in the future, the amount of matter in the universe will be so great that gravity will cause the expansion to slow down and stop. Then, it will reverse, causing the universe to contract until it combines into a tiny point called a singularity before expanding out again, triggering another Big Bang and resulting in the birth of a new universe. This process could happen again and again. Our universe and future universes stuck in a never-ending cycle of contraction and expansion. It is worth pointing out that the timescales here leave plenty of time for fun, including studying more astronomy. Given everything people have learned since our earliest days, hardly the blink of an eye as far as the universe is concerned. It would be very surprising if we didn't have a huge amount more to unearth. Perhaps the most exciting knowledge is still out there waiting to be discovered and will cast our whole understanding of the cosmos in a brand new light. Maybe you'll be the one to transform what we think.
It is all too easy to think of the Big Bang and the resulting expanding universe as being like an ordinary explosion, with everything expanding out from a central point. A better analogy is to consider the surface of an inflating balloon where the surface is a two-dimensional equivalent of our three-dimensional universe. The balloon fabric is space. Dots marked on this surface equivalent to galaxies will move apart as the balloon expands, but only because the fabric space itself is expanding, and without any central point for the expansion. The balloon is expanding into the third dimension, but here the analogy is more problematic. Is our universe also expanding into a higher dimension? If the universe is all there is and isn't part of a larger multiverse, then there is nothing outside it, not even a vacuum, which is still space, so it probably makes no sense to ask what it is expanding into. Nick Canning, Coleraine, County Londonderry, UK. A two-dimensional being on the surface of an expanding balloon can observe all distances in its surface world getting larger. It can't see the third dimension into which the balloon is expanding. We three-dimensional creatures see all the distances between galaxies expanding, indicating an inflation of space, but we can't perceive extra space dimensions beyond our three into which the expansion is taking place. Roger Leach-Batt, UK. There are two parts to the answer to this question. First, when mathematicians and physicists want to describe space, any space, the mathematical tools and techniques they use don't depend in any way on the space being part of a higher dimensional space. So they can, for example, do geometry on the surface of a sphere without considering that the sphere is embedded in our everyday three-dimensional space. Four-dimensional spacetime is more complicated than the surface of a sphere, but the idea is the same. It is possible to calculate the shortest distance between 2 points, for example. Second, if space is expanding into some higher dimensional space, we can't, with our current knowledge of physics, know anything about it. And it may even be beyond our comprehension. Mike follows. Set in Coldfield, West Midlands, UK, this isn't a question that physics can answer with our present knowledge or without some form of qualification. The trite answer is that both space and time were created at the Big Bang about 14 billion years ago. So there is nothing beyond the universe. However, much of the universe exists beyond the observable universe, which is maybe about 90 billion light years across.
If the universe is infinite, there is nothing beyond it by definition. A finite expanding universe conjures up the idea that it would have a boundary or edge, separating it from something beyond. Of course, the universe has at least 4 dimensions, 3 for space and 1 for time, which is nigh on impossible for us to visualize. However, space could be represented as to dimensions confined to the gossamer thin surface of a sphere. You could travel in any direction on the surface without encountering an edge. If the radius were to increase, the universe would expand as ours does, but it wouldn't be expanding into anything. Finally, we could speculate that our universe is part of a multiverse with many other universes beyond our own, but it is unlikely that we are expanding into them.